Yes, you need your notebooks today and the note sheet. The note sheet, we're just going to use it towards the very end. So all the examples today you're going to put in your notebook. So we're going to still use the Pythagorean theorem. And this time, instead of using a calculator to estimate, we're going to leave it in a more exact form. And we're going to use the product property of square roots. So you're going to have square roots in your answer. So your answer might look like C equals 2 square root 10. So that's how your answer might look. It'll contain a radical sign. And what this means is 2 times the square root of 10. So this is more an exact answer. You're not estimating. And with this, we're still going to use a formula, c squared equals a squared plus b squared. If you were absent yesterday, then you can kind of see what the homework is like, or from yesterday. It's the same concept. So we're going to look at the product properties of square roots. So we can look, if this was one number, AB was one number, we can split it up into A times B. So like A, if it's underneath one radical, we can split it up. So let's look more at a concrete example. Square root of 72. I can figure out what times what is 72. And I see 36 times 2, so I'm going to break it up. Now, can I take the square root of 36? Yes, it is 6, so I bring it out. And then I cannot take the square root of 2 unless I estimate. I'm not going to estimate today, so I just leave it. So your answer would be 6 times square root of 2. Now, some of you see 72 and you don't think of 36 and 2. You might think of 9 times 8. Well, in that case, another way to do it is to do a factor tree. So I'm going to do a factor tree of 72. So I start and I see, okay, I can divide this by 2. 2 times what? 36. So maybe you don't see that this is a perfect square. So you're going to say, I have 2 times 18. And then I can still break up 18. 2 times 9. Can I break up 9 into prime factors? 3 times 3. So here's all my prime factors. So what I can do is, I can take, if this is a square root of 72, and I can put all of these, and I would group the like numbers together. 2 times 2 times 2 times 3 times 3. So what is a square root? It's one of 2 equal factors. So here's 2 equal factors, here's 2 equal factors. So I'm going to take one out. I'm going to get rid of the other one. I'm going to take one of these equal factors out, and I get rid of the other one. Well, what did I take out? I took out a 2 times 3. 2 times 3 is 6. That's what I took out of the radical. What's left inside? 2. There's my answer. Did I get the same answer? Yes. So sometimes you're going to want to do a factor tree. Now, if I did this and I divided by 2 and I saw 36, right away you should start thinking, oh, 36 is a perfect square. I can keep that and take the square root of 36. this is just going to stay left inside. Okay? But maybe on the factor tree, you broke it up into 8 times 9. And then you said, well, I can still factor those. 2 times 4, I'm going to circle that. And then 2 times 2. And then this would be 3 times 3. So here are all my equal factors that you put inside. Okay, so either way I split it up, I get the same thing. So let's try some together. So write down this first one, square root of 32. So let's do a factor tree. What times what is 32? Yes. 8 and 4. Okay? So, yes, I know 4 is a perfect square. So there's a couple ways you can do this. You can say, okay, 4 is a perfect square, so let me break this up. What times what is 2 times 4? All right, here's 2 equal factors. Like, what if I did this? 4 times 4 times 2. Okay, I have 2 equal factors here. Or I can take the square root of 4 and the square root of 4. Either way, you're going to get the same. So, here's 2 equal factors. I take one out. I get rid of the other one. Can I take the square root of 2? No. So I'm going to end up at 4 times the square root of 2. That's my answer. Now, if you have a hard time, with this, I would just go to all prime factors. I would just keep factoring my factors until you get all prime factors. And so what happens is it looks like this. You have how many? 5? 2 times 2 times 2 times 2 times 2. For some of you, this might be the easier way. For some of you, this might be the easier way. It depends on, where you are in math. So, one of 2 equal factors. Here's 2 equal factors. Here's 2 equal factors. So I'm going to take out a 2. I'm going to get rid of the other one. I'm going to take out the 2. I'm going to get rid of the other one. So 2 times 2 is 4. And then what's left inside is 2. So whichever way you decide, it's going to give you the same answer. All right, write down this one. Square root of 41. Write that one down. Okay, let's see if we can factor it. Can we divide it by 2? By 3. How do you test 3? Add the digits. 4 plus 1 is 5. Is 5 divisible by 3? No. How about by 4? Before we go into that, 5, 6, 7, 8, 9. So, you cannot factor it, so this answer would just be left the square root of 41. All right. So, how can we factor this one? What times what is 75? Nicholas? Oh, we're on this one. We're going to do this one. Sorry. Square root of 75. What times what? Okay, so he said 3 times 25. Now, you can continue to prime factor it, but this is prime, right? Is this a perfect square? Yes, and this is prime. So I would leave it like this. square root of 25 times the square root of 3. You can break it up. What's the square root of 25? And then you cannot do anything with that, so you just put it right next to your answer. There you go. Okay? So I want you to try this one. Square root of 20. I know. Okay, what times what is 20? Huh? 4 times 5? All right, so we have a prime number here. The other one either has to be a perfect square or prime. Is it a perfect square? Yes, so I can separate this into this. Square root of 4 times the square root of 5. So what's the square root of 4? And can I take the square root of 5? No. How many of you had that? Okay. A few. Not too many. If you wanted to go again to prime factors, you would just break that up into 2 times 2. And so what you end up with is 2 times 2 times 5. And then what are you looking for? Here's 2 equal factors. Take 1 out, get rid of 1. So I took out a 2. What's left inside? 5. It's the same answer. Either way works. All right, so let's put that into place into the Pythagorean theorem from yesterday. So write this down. Spell this out. It's going to be all of us. All right. The missing side is what? A, B, or C? B. Now, if you were absent yesterday, the sides that make up the right angle are A and B, and you can interchange. I can call this side A and this side B, or this side A and this side B. It doesn't matter, but the side opposite is always side C. So we're going to write our formula. C squared equals A squared plus B squared. And if you write it this way, tomorrow it'll really help you. So we know C squared is 12 squared equals 10 squared plus our unknown is B squared. So 144 equals 100 plus B squared. How do we solve for B squared? Subtract 100, and I get 44 equals B squared. Now I'm going to take the square root of both. Square root of B squared is B. Now let's factor out this 44. So what times what is 44? 4 and 11. So 4 and 11. 11 is prime. Is the other one a perfect square? Yes, so I can take the square root. So I'm going to have the square root of 4 times the square root of 11. What's the square root of 4? And can I take the square root of 11? So just leave it inside. There's my answer. Is that easier than estimating to the nearest tenth? You know, finding out what does square root of 44 come in between, and subtracting and dividing. So we did this way instead of the estimating to the nearest tenth. Okay, let's do another one. Write this down. A. And then the 10 is B. Remember, they make up the right angle. Side opposite that right angle is C. So formula, C squared equals A squared plus B squared. C squared is 11 squared. A squared, I don't know. B squared, 10 squared. So what's 11 squared? Equals A squared, and 10 squared is 100. Okay, how do you solve for A squared? Subtract 100. So 21 equals A squared. So now I'm going to take the square root of both sides. Square root of A squared is A. What's the square root of 21? Well, let's look. Here's 21. What times what is 21? 7 and 3. Well, they're both prime and they're not perfect squares. So it would just remain square root of 21, not 21, square root of 21. All right, next up. Write this down. Label your sides. Oh, here, we're going to change this one to 4. Sorry, there was an error on the slide. Okay, label A, B, and C. Okay, the missing side is side what? C. So, again, you can call this A and B. Doesn't matter which one you call A and B. You can interchange those. So, fill in your formula. C squared equals 8 squared plus 4 squared. So, find out what C squared equals. What's the total number? So you should have had 64 plus 16. C squared is how much? 80. Okay, I want you to try and factor out 80. See if you can come up with what C equals. So do the factor tree if you're not sure. Do a factor tree. If I factored out 80, it can be 2 times 40. 2's prime is 40 perfect square? No. So I can factor out 2 times 20. So since I have already started the factor tree and I have more than 2 factors, I'm going to just keep on going to prime factors. 2 times 10, and then this is 2 times 5. So there's all my prime factors. So I'm going to just put them under a radical. 2 times 2 times 2 times 2 times 5 So, one of two equal factors. Here's two equal factors, here's two equal factors. So I take out a 2, I get rid of the other one. I take out a 2, I get rid of the other one. So 2 times 2 is 4, and what's left underneath? 5. So C equals 4 times the square root of 5. How many of you got that? All right. And you could have done it several different ways on that factor tree, but you should have still got 4 times the square root of 5. All right, here's yours all by yourself. Go, the whole thing. Hold on, I forgot to press record, so it was, okay, there you go. What side is missing? What's this side right here? C. So let's go. So what times what is 52? 2 and 26. So 2 is prime, but 26 is not a perfect square. So what times what is 26? 2 and 13. So we have 2 times 2 times 13. 2 and 2 are equal factors, so take 1 out, get rid of 1, and I can't do anything with 13, so what I have? 2 times the square root of 13. Okay, and technically we should be labeling these miles. Your answers should be labeled. This one I'm not as picky, but you should be labeling them. All right. So, on the note sheet, I'm not going to go over this one because I did, before the lesson, I really stressed, what is this line right here? A. Okay, so that is an A. What is this line? B. And this outer line would be C, so that would be your unknown. Okay, I'm not going to do these because it's the same process. Let's look at the back side of the note sheet where we have this word problem. So the 4-box method is just a way to help you set up word problems. So this one says, the lawn in front of Pioneer is in the shape of a rectangle of 24 meters long and 10 meters wide. How many meters shorter is your walk if you walk diagonally across the lawn rather than along two sides of it? So what shape do they say the lawn is in? A rectangle. So we're first going to draw a picture. So here is my rectangular lawn, and it says it's 24 meters long by 10 meters wide. So if I'm right here, and I want to go over here, I can do what? I can walk around the lawn. I can walk 24 meters this way and 10 meters up, and that would be what? 34 meters. If I walk around. So if I walk around, it's 34 meters. Now, what if I walk diagonally across? So, how can I walk diagonally across? How can I figure out that diagonal? I can use what? The Pythagorean theorem. So here's my right angle. What side is missing? Side C. So these would be A and B. So A is 24. So 24 times 24, I think it's 576. 24 squared, 576. On the word problems, if you have big numbers, you can use a calculator. On the other ones, you can't. Okay? Just the word problems. So B is 10. So 10 squared is 100. And we don't know C, so C squared. So that's the second part, is just identifying. And then you've already did like the first couple steps over there. So now we're just going to put it together. We're going to solve it. But when you do this step, you already substituted it in right here and calculated. So now we're just going to put C squared equals, and then A squared was 576 plus B squared was 100. So C squared equals 676. So I know it's bigger than 24 because remember, C is your longest side, so it's your largest number. So the square root of 676 is 26. So C is 26. So if you have a number like 676, just you can use a calculator. It's large. Only on the word problem ones. And one of them tells you to use a calculator. Okay, the other one, I think the numbers are small. So if my diagonal is 26 meters. So instead of going around at 34 meters, the diagonal is 26. So I would say to walk diagonally across the lawn. Okay, go across. It would be 26 meters. Okay, so what is it? So what does it say? How many meters shorter? So then you would say 34 minus 26. What's 34 minus 26? So this is 8 meters shorter. Shorter than walking around. All right. You want to pass out that homework? All right. The last one, we're going to draw up the Okay, real quick, guys, while the homework is coming out. Quiet, please. Okay, Ms. Bond went camping with her family, and they left the campsite. They went 8 miles north and 15 miles east. And then you would find that diagonal. Okay? All right. Oh, real quick, on number 10 on your homework. Cross off number 10.